Now let me talk. Let me talk next about the accuracy of our system. A lot of people, most workstations, many workstations out there, are simply not accurate when pipetting small volumes at all. I made a quick reference to that. Let me. Our published accuracy and reproducibility is actually understated in our manual. We have a third party, that has a multi-channel verification system they call RTEL Engineering, and they evaluated our workstation and found that we could deliver less than 1.6% imprecision, a CV imprecision at 1 microliter when using our 1 to 50 microliter tool. And when they did a similar evaluation on our 0.2 to 10 microliter tool, it was even better than that. And I can share that with you if you like. I can certainly send you this as well. This is the best published precision and accuracy that we can find anywhere. So you can be rest assured that if precision or accuracy is important, then we can certainly do it. Even if most of our competitors cannot. I'm going to cut away from this for a moment. We're going to get back to programming in a minute. Let me show you a couple individual items. If you could please go back out to the wide view. Let me talk about some of these accessories and stuff that will do what I just was describing to you. This is the basis of our systems are the main tools, single and multi-channel tools that you put them onto the deck because at the beginning of a run, or you leave them there all the time. Most of the time, people will have will not need more than 4 because there's a lot of overlap in the volume ranges. Most people won't need more than 4 tools ever in the course of a protocol. So you simply leave them on the deck. The machine looks and finds for itself where those tools are. It knows what it needs to run the program that you've just assigned it to do. And so it'll go and look at this. It will look here at these the chips. There's little chips here. The chips actually identify the serial number of the tool, the last calibration date, and it keeps a running tally of the amount of the number of pipetting strokes since the last calibration date, and it will let you know if you are out of calibration. If you've gone more than a year or 200,000 pipetting strokes, it pops up with a message. You can bypass the message if you wish, but these are the essence of simplicity. They have a worm drive that drives the pistons up and down, and they can do this with a far greater precision than a human being can. So we will talk about that. We'll talk about that, a little bit more later.
Okay.
Any questions about this?
I saw in the Hamilton they have capability to do tip moving independently. Is it possible to do epMotion?
Independent movement?
Yes.
What are you saying? Independent. Okay.
Tips movement, yeah.
Okay. And why do you think you would want that? I'm just kind of curiosity. Why do you think you might need that?
Well, I mean, sometimes you just need like 1 tips, and sometimes you need multiple tips, right? If for example, if you want 2 tips or 2 aspiration position, Hamilton might be able to do it. I don't know if epMotion is able to do it or not.
Okay. Well, okay. Let me put this down so I can address this. Okay, I can see where you're coming from. I understand your concern. It sounds like an interesting thing, right? The idea being that you have like individual heads rather than having them fixed in a tool like we have. You have them independently, and so when doing an aspiration from say tubes to plates, what you would see is it would extend a leg, drive down with the with an independent channel and aspirate one, move over, and then move down and aspirate another one, and then move over and then go down and aspirate. another one, and then go over and move and so on. And then it would move over to a new location where it would go down directly into, say, the plate or something like that, right?
Yeah.
That's what you're
Yes.
describing, right?
Yes.
Okay. All right. On paper, that sounds like a interesting innovation, but I can tell you that our machine is this way, this here, 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 here. So it is going to take a little bit longer if your stuff is set far apart on the deck. The only benefit that such a system would offer you is it'd be marginally faster. On an NGS assay where you have a dozen different liquids being dispensed, you may have to it may take a little bit longer, but that time is not hands-on time. Okay, what most people want to do when they're what most people care about is not so much how much time the run is going to take, as they are concerned about the amount of time they're actually have to spend with it, and will they have to watch it. So I've done demonstrations to customers who've tried automating NGS on a lot of those types of workstations, and it's amazing that virtually they virtually never seem to work, and they run into all kinds of problems. And let me explain why. You go into yes, you do. You have, first of all, you have this incredibly complex mechanism. Instead of having one drive to put in the proper XY position, and another drive that moves, the one drive that the worm drive that drives the piston up and down. Instead of a simple system that is reliable, robust, and going to last for years with very little need for service, what you have instead is this incredibly complex thing with independent movement for each and every one of these pieces. There's an engineering principle that says the more complicated the system, the more likely it's going to break down. You have something that has hundreds of moving parts versus something that has 2 moving parts. You're going to have 50 times the number of breakdowns simply because you have 50 times as many moving parts. So you have to accept a lot of downtime, right? The machine is going to be down a lot. It's going to require a lot of service, and it's going to be more expensive to maintain over the long run. So
that's true. Yep.
For this reason, we focus on reliability and on getting the job done. How many plates of okay, you only have one sequencer. Do you have just one sequencer?
We have only one sequencer.
Yeah, one
and
sequencer.
It's at the core, yeah.
Okay.
Core facility.
One sequencer. Okay. One machine can already handle the throughput needed for one sequencer. One workstation can do that. So making it faster will not give you any benefit, right? It's speeding it up a little bit. So you'd be trading off the complexity you'd be trading off a bell and whistle that would be really destructive in the long run, because it's more expensive and more complicated, and like I said, produce a lot of downtime. So there's that issue. But there's another one too, and this one is one that you wouldn't normally think of. When these independent channels come in and they drive up and down, they all have a certain tolerance, right? Every machine has a certain tolerance. They're going to be plus or minus so many microns, 50 microns or whatever. Well, each one of these things will try to line back up when they go over into the plate. They'll need to line up, and the reason why is because, say you're going into the plate to aspirate out waste. You aspirate out the waste. You need them to touch the bottom of every single well simultaneously with the same amount of pressure. Otherwise, you don't get all the liquid out. And we all know what happens, right? When you don't get all the ethanol out at the end of a wash cycle, what ends up happening is you end up losing all of those wells that have any residual ethanol in there.
That's true,
they won't dry in time, and then your whole program is scrubbed, and you've wasted thousands of dollars on reagents for a run that is potentially compromised. It's for this reason that Eppendorf focuses on reliability, reproducible, accurate, lower cost, more reliable, robust system. And that's why our system is dramatically superior, because it does not have that option.
Okay.
Okay.
That's good explanation. Yeah.
Okay. Similarly, some people also ask, and I'm sure you're probably going to be the next thing you might have asked too. I don't know.
Yeah.
Would be like, what about like bigger heads, right? What about 96 channel heads, right?
I know.
Okay.
I know the EP96 have 96 channel head. Is it possible to put it in the epMotion, or they do have it?
Oh no, well the epMotion 96 is a semi-automated workstation, and yes, it can be used to move things from place to place and such, and it does. It can do simple applications. It can't be put inside of our workstation now. It could be. You could set up an application where it would prompt you to remove things, move them from one place to move. You could prompt you to intervene, remove it, put it on the epMotion 96, do a 96 channel thing, put it back on the workstation, and then continue, pick up their assay where you left off. You could do that if you wanted to, but I would say that most people don't opt to do that, mainly because like when our machine delivers reagents, for example, okay, first of all, a 96 channel head is incredibly limiting. Okay, think about it. How often do you actually do a full plate?
Not really.
Right? Yep. I mean, right? And most people don't. Most people are doing smaller subsets of things, right? So what good is what good is a 96 channel head if you can't use it most of the time? It can only be used in those steps where the same thing is going to everything in the same well, right?
Yep.
Okay. There's also two other really good reasons. One of them is called planarity. Planarity is why it's a terrible choice to use a 96 channel head for doing this type of thing. And let me try to demonstrate that. Let me get some tips over here and a multi-channel tool and a plate. Okay. Our machine attaches tools. So if you have to get that the camera's up there and not down here, I'm looking at what I'm looking at. Okay, so the machine goes into the well. Our machine can rotate a little bit. If the tips really have to line up perfectly, okay, when you attach tips, the more tips you have, the more likely that one or more of the tips is going to be not seated quite as deeply as all the others. Okay, that is just a fact of life. Okay, now when you attach 96 tips, you have flexion of the plate that you're aspirating from, so the tips will not always seat perfectly. And guess how many tips it takes if you had just one tip that's a fraction of a millimeter further out? Okay, just a fraction of a millimeter further out, and then you go into a plate to remove all of the waste from the plate. That one is jutting out. Guess how many samples get pipetted properly out of that 96?
95.
One
Okay.
pipette. One sample gets pipetted properly. All the others have residual ethanol be left behind. So when you deal with a 96 channel head, you have to also deal with all the drawbacks of that. Now it's appropriate for for people with very, very low tech applications. I want to take 50 microliters here and put it over there, and I got tons of liquid over here. That's not a problem. Okay, sure, you can do that. Our epMotion 90 kit can do it for a fraction of the money of a full-size workstation. So we have that. I understand the attraction for some people when they're doing that type of work. But for this type of assay, or for any assay requiring a high degree of precision, a 96 channel head just doesn't help you in any way. Our machine, on the other hand, with eight tips, we can seat them quite precisely, and we also have that option where it will not. You're far less likely to leave a tip for an excess tip to have this problem because you have some flexion here. Even the tips will if when you hit the bottom of a well or something like that, the material is soft enough that it will sometimes flex a little bit to the side. You won't see that with a 96 channel head. But what do you lose? Well, okay, a 96 channel head, way more expensive to buy up front, way more expensive to service every single time. You drastically increase the cost of your service contract every single year. You can only use it on a few very low benefit systems. So it's a very it's frustrating. I think it's incredibly frustrating to have this really expensive thing that really you can't use very much. Does that make sense?
Yeah. Yep. Makes
okay.
sense.
Let me put that back. Okay. The other things that let's see. What other things I wanted to show you? You know, this is an example of something that was originally a custom-made adapter. People had a specific problem. They wanted to put a lot of tubes on the deck. We developed this this thing so that it could fit over a thermal element. It could sit on the deck, cover 2 deck positions, but hold 96 tubes. Instead of using 4 deck positions to deliver from a large amount of tubes, you can use 2 deck positions, accomplish the same thing.
Mhm.
And the caps sit in the upright and open position. So if I were to put a cap, if I were to put a tube in here like this and push it down into the rack, it stays in the upright and open position, locked, so it can't interfere with the thing. This is an example of just how innovative a a custom piece can be. This is now available off the shelf. You can simply purchase one now without having it waiting for it to be custom made. But this is just a sample of a solution for you. The 96 well ring magnet is how you will accomplish the plates will sit here on top. The machine will absorb the impact of the tips, so when you strike without striking the bottom, and they'll also make a very tight ring with a very low elution volume. This is a EX, but an FLX magnet will allow you to do extremely low elution volumes, so you can get away with that can be useful in certain applications as well. So just an example. This is a tip tool, kind of a nifty little device. It allows you to rebox tips if you decide you want to. One single piece can use works for all your tip sizes. So you don't have to switch out things like that if you do decide to rebox. I'll explain to you later why it's not necessary to do that. Not necessary to rebox all the time. Thermal adapters. We'll use thermal adapters that make good contact with the thermal element built onto the deck to keep your samples at a uniform temperature, very close to the target temperature that's in the element below it, and it makes really good contact with the deck. This is something that I'll be using here in a moment when I do the demonstration. We have a gripper. The gripper is our gripper is incredibly robust. I've had people who've been using these things and they virtually require no service whatsoever, no calibration, no maintenance. Stick it on the deck and forget about it, and the buggers last for decades. They're again, simplicity of design. The gripper can move anything around the deck weighing less than 1.2 kilograms. That is soft enough to be soft enough for this to bite into it. So it wouldn't pick up something. You wouldn't pick up something very heavy metal, hard metal, unless it had a grip point built into it. Okay. I think I've covered. I've covered in the big picture some of the accessories that I think are salient and potentially of importance to you. So let's I think we can go back over to the let's go back over to the computer here for a moment, and let me talk a little bit about programming. Programming is probably the most important feature of any workstation. When we launched this product, we of course interviewed many customers who use different automation systems, and we found that they were vastly underused. And the number one reason that people cited for that was not incapability of doing it, but it was just too complicated. Many systems require you to go away. Some systems require you to go away. I'm sure you've heard about the Hamilton School.
Yeah,
You go away for a week or two to learn all this line programming. Incredibly expensive. People learn, leave, and then the machine's dead because you can't simply do it. So software is really critical. And I would have to say that in all these years that I've been working for the demonstrating with Eppendorf, I've talked to people using every other system you can imagine. I have yet to find not one customer who did not find our system to be easier, substantially easier than what they had used before. So we'll get to that in a little while. Machines like ours do depend on what's called labware definitions. They're mathematical representations of the items that you're going to be putting on the deck. And let's face it, it's a pain to try to teach a machine. The good news is you don't have to do it. We'll do it for you, and we'll do it at no charge. We've already have a labware library consisting of thousands, tens of thousands of different pieces that were defined for other people, and those are accessible just by asking. If it's something new, if you needed us to define something different, just simply arrange with the BioApps Lab to send in that item. We will do all the appropriate measurements and have a definition emailed back to you, usually within a day or two. It's usually pretty quick. Our software will allow you to check your protocol before you even run it, several different ways. There's a check feature. There's also a simulation mode and a quick simulation mode, which is simply a mathematical test, and a virtual simulation mode where you'll be able to see the machine operate, run the application that you're looking at. And so you know that that's what, if you wrote a program, you know that that's what you had in mind, and then you can go on from there. Okay, so you'll see that all in just a moment. I don't want to spend too much time on this. So let's talk about this optical sensor. You don't need to cut away to it at the moment, but you'll see here in a little while that that there is an aluminum tube on the right-hand side of our pipetting head, and these are the eyes of the machine. The eyes can see. The majority of workstations actually do not have anything like this. They cannot see they cannot see what's on the deck, and so they cannot do any of these items. And these are so important. Most instruments, in fact, let's talk about this first feature, the contact-free liquid level detection. Contact-free liquid level detection is so critical. Most machines that when you have an application where you need to know the liquid volume there, most machines have to attach a conductive tip. The conductive tip pierces the surface of the liquid, and then it senses a change in electrical impedance, and it says, okay, you're in the liquid here. All right, at this point, you're in the liquid. And then it can figure out, it will work from that. But our machine goes way beyond that, okay? Our machine reflects, uses a confocal infrared laser to reflect off of the meniscus. It records the meniscus height. It goes into the labware definition, uses in the labware definition, it has a means to calculate the residual volume. So without touching anything, it knows how much is there. Why is this important to you? Well, if you're going into an unknown container, you don't have to touch that liquid to dispense close to the surface and then not have to change your tips afterwards. So whereas most machines, you would not trust that. You would simply have to change out your tips every single time you go into the well. With our machine, you can be concerned. You can be sure that the machine will stay away from the liquid that's already there. And it does back up as it dispenses to stay away from the rising liquid levels, and also drops down as it aspirates to keep pace with falling liquid levels in the aspiration stroke. So this is a widely important feature that is simply not available on most workstations. It tells you before you walk away from the machine whether you have enough liquid, and it even keeps track of the dead volume and mixing volumes and all of those things, so it knows whether the machine can do what you've asked it to do. The second bullet point there, that checks the deck configuration. This is like so important because if you put things in the wrong place, and humans always do, all the time, sooner or later you're going to do it. Most machines will just go there thinking that there's something, and if that item is higher than the item that's supposed to be there, it will crash into that item. It could cause steps to be lost on the Z-axis. It could cause damage to the Z console. It can cause It will certainly need to be recalibrated if you crash the machine. With our machine, the machine checks the deck, compares to what you have in the software, and tells you right up front. That doesn't look like you have the right thing in the right place. It lets you fix your mistakes before they damage the machine. So that's another super important feature. And finally, tip detection. The machine can detect detect the location of those tips that are placed on the deck. If you have a partial box of tips, you simply leave tip detection on. All of these things are defaulted to on at the beginning of a run, but can be shut off in certain situations. So the machine, you do not have to rebox your tips. You do not have to reorganize them in any way. You simply leave your partial box of tips on the deck. The machine works around it. And that's
so can we use some other brands tips like USA Scientific tips in epMotion?
Well, the machine does. The answer is no. You don't have to. You can't use that type brand of tips because it's not designed for our workstation. There are other aftermarket tips on the workstation. Other people do sell tips that will work on our workstation, but we don't recommend it simply because the quality is not there. I've had a great deal of I have a lot of experience visiting customers. I'm talking here well over a decade, just focused on this one product. And I'll tell you what, I get called. I do ask people all the time if they ever had problems with our machine. One thing that they complain about with many workstations is like, oh man, I got to babysit this machine. I got to be there. With other machines, they've always tell me that I've have to babysit. I can't be gone for very long because the machine will misattach something and it will mess up a run. I will have all these problems. Well, that is not a problem with our workstation. In fact, for the better part of my tenure with Eppendorf, I had never experienced a single person who had a tip failure to attach a failure to attach tips. And then I got one time I got out of a blue, I got a crash issue. And so I had a crash issue, and they complained, oh, your machine had issues or whatever. And so I go in and looked at it, and I said, what had happened is the tips had come off. Now I'm going to try to get this into the view here. It's a little hard for me to do that. Well, you won't be able to see it really on the thing. But right here on the rim of each one, it's actually printed. Eppendorf is printed on that little thing. You're not going to be able to see it with the thing, but I'm welcome to show it to you later. But that tip, when I looked at that, I was like, oh wow, it doesn't say Eppendorf on there. Where'd you get these from? And they said, well, we got the thermo. We had thermo tips, the epMotion tips. They had advertised the epMotion tips, and so I was like, interesting. I was like, let's try it with our tips. Let's try it with our tips. And it had crashed using an alternative tip, simply because the tips didn't attach in the proper way, caused a problem. So we don't recommend that you use those other tips. There are some people who use them and they get passable results, but for a very precise application like this, I would say it's better to stick with something that we know is not going to damage the machine. Now, okay. The good news is, have you ever used Eppendorf tips on the benchtop?
Yes. Yeah.
Okay. Well, the good news is if you use our benchtop tips, you use our benchtop tips, these are cheaper. They're cheaper. Most of the time, automation tips are more expensive. Okay. Yeah. And the vast majority of the time, but our tips, our automation tips, are sold direct from us to the customer, and so we don't have to build in a margin for the dealer. The dealers, most of our benchtop tips are sold through distribution channels, things so on. So there's a little bit of a markup. So in most cases, when I compare what people pay for EP tips on a workstation, they end up actually being a little bit less than the ones they were paying on the benchtop when they were doing it by hand. So that's a good thing, right?
Good news.
Save a little bit of money and also get a better result. No, that's food for thought. Let's talk just a little bit about free jet dispensing. Many times people do ask, when you dispense small volumes, what do you do? Do you go to the bottom of how do you touch the sides? And like, how do you get the liquid to come off and reproducibly and all that kind of stuff, whatever. And I'm like, wow, you don't need contact-free pipetting to do that. You can do that with our machine because our machine is designed to do freeze-jet dispensing. Many machines can't do this because of the way that they do the aspirations. They have system liquids and other and peristaltic pumps that just simply cannot do this. So our machine can do this. It will automatically build in a certain amount of the liquid class will build in an additional air volume. That air, it'll pick up the air stroke. It'll start the piston farther back and then back up as it aspirates the liquid, goes to the receiving well. It does pull a trailing air gap to prevent expansion of dripping from occurring as it moves across the deck. But then it closes down that trailing air gap, spits out the desired volume, and then pulls another trailing air gap before it moves to the next location. Okay, it does this. It can do in multi-dispense mode. It cannot do the blowout, but in pipette mode, and you'll always use pipette mode when you are doing super low volumes that are too small to cause a free falling drop. So you'll use pipette mode, and in pipette mode, the machine will push out the desired volume and a predetermined volume of air. So it's extremely reproducible. You got to wonder, how in the world did we accomplish a CV of 1.6% with a 1 to 50 microliter dispensing tool, dispensing a super small volume down to a microliter? Oh gosh, I just noticed something. I never changed that thing because technically we can go down to 200 nanoliters with the small volume tool. We can actually go lower without touching the sidewall. That is a mistake. I need to change that in my presentation. I have been there for quite a while, actually. So also, you also might say, well, how is it going to pipette glycerol and other liquids that are thick or have a high vapor pressure and so on? Well, we have preset liquid classes in our machine. You simply choose the appropriate liquid class. Use ethanol. Use the ethanol settings for things with high vapor pressure. Use the glycerol settings for viscous liquids up to say 20% glycerol. And the machine changes the way it pipettes. It will allow more time to get liquid to get in, more time for liquid to settle at the bottom of the tip before blown out if it's a viscous solution. With your pipetting ethanol, the machine will even pre-wet the tip, pull liquid up the tip and spit it back out. And what that does is it saturates the airspace above the liquid column, prevents that expansion from causing the liquid to drip or pop out of the machine. So that's why our machine is exceptionally well designed, because it takes advantages of, well, it uses every benefit we can by engineering it to work specifically with different types of liquids and still get a good result. My final slide deals with maintenance. And everybody, right? Everybody you probably talk to says, "Oh, no, we got super reliable systems, or whatever." It's easy to say, okay? But I wanted to explain to you why our machine is so much more robust and reliable than other machines that you may look at. Okay, you notice that if you look at systems that have independent channels, well, guess what? Most of them have hoses that run off the top of the independent channel that runs back to a pump, and those pumps can sometimes be loaded with water, or liquids. Those liquids are require a great deal of routine maintenance, and you don't have to deal with those types of issues like crystal formation, like bad seals, like liquids or liquid or that can cause breakage and that can cause problems. There's no maintenance with our machine. There's nothing to replace. Like I said, it's a simple worm drive that drives a piston up and down. It's a simple essence of simplicity, and simplicity means far less labor, far less work. Service reports that the average time to the very first hardware failure that will occur requiring replacement parts is 4.2 years. That's what they say on average. We sell a machine, and before they have to replace a part on that machine, it typically happens around 4-year mark. Well, I came from a lab that had a lot of different types of liquid handlers in it, and I'll tell you what, we had a service guy on some of those machines like all the time. Basically every week. There was not a time when there was somebody there. And things broke all the time, and there was just an enormous amount of maintenance. Well, that is not what you will experience with this. We do not have peristaltic pumps. We do not have anything here other than that simple worm drive that does not break anywhere near as easily as other systems out there. The pipetting tools are calibrated a lot like a traditional pipette, right? So you once that machine prompts you for calibration, you mail in your tool, you have it calibrated, you have it they'll calibrate it and return it back to you. Usually a matter of a days. Now we got backed up a little bit during the pandemic, and so there's been some because there was a machine that went down that we couldn't replace or fix properly. But that's kind of a rarity. And under normal circumstances and normal times, you will get your tool back in a matter of days. If you cannot do without a machine at all, you can also request loaners, or you can get an additional set of dispensing tools at a greatly reduced price, 40% off list. If you decide that you want to have a second backup set of tools, let me know, and I will try to get that included as well. Okay. This system is, as you can see, it's completely enclosed. It keeps it from external elements. It keeps it clean. It's definitely better to have an enclosed system rather than an open system. We also offer a full range of on-site service and preventive maintenance plans. Some people are shocked at the price. They're pleasantly surprised by the price of our service plans and what we offer with that. We have a basic maintenance, a basic preventive maintenance for 5073 workstation. It's $2,500, $3,000, something on that range. It includes on-site visit, clean, calibrate, lubricate, do free upgrades of your software. If you desire that to be done, they will also recalibrate and test it to make sure that it meets all the original specifications. It also includes mail-in calibration for up to 4 dispensing tools per year that can be sent in at your convenience. For a small additional amount, it varies between workstations from like as little as $1,000 more to as much as a few $1,000s more. You can add in what's called a limited service coverage. So we have an Advantage OS plan, which does include it can include two repair visits, all parts, labor, and travel for 2 repair visits should you require them, or a preventive maintenance visit and a breakdown visit, a 6th visit should that be required before the end of the calendar year. These are very, very affordable. We also have a premium and custom plans. Premium plans would include unlimited coverage, all parts, labor, and travel for unlimited visits over the course of the year. And for a large workstation, for a mid-sized workstation, small workstation, it would be $5,000, $6,000 range. For the mid-sized workstation, it's going to be a little bit more like $7,000 to $8,000. For the largest workstation, it would be somewhere in the neighborhood of around $11,000, $12,000 or so. If you purchase multiple years, we can give you additional discounts on multiple years at the point of sale. So you can take away the risk of the price going up later on if you just go ahead and buy a longer term service contract at the time you purchase. Any questions about that before I move on to the software?
Nope.
Okay. I'm gonna move over here and start to I'm going to give you a little view of our software and then run a program for you, okay?
Okay.
Can you see I will
Yes.
not be able to see the monitor while you're, I will not be able to see the monitor, so hopefully you'll be able to see it. Let me know if you can't see this.